Welcome back to Coolant U, the 10-part video series that helps you reach a higher degree of knowledge about engine coolant. Made possible by RecoChem, your partner in formulating solutions. In Module 8, we'll learn how heavy-duty engine coolants are specially formulated to meet the evolving needs of the market, including the cooling demands of today's diesel engines, increased use of aluminum components, and the move towards new nitrite-free corrosion inhibitor technology. A coolant formulator's job is never done. Today's heavy-duty diesel engines are more compact, run at higher temperatures, operate under increasing loads, and have new emissions control systems. Their cooling systems are also evolving, with new componentry demands added that require additional thermal protection. As heavy-duty equipment becomes more advanced, their engine coolant formulas have to do the same. HD coolants are far more than colored fluids. They are precisely formulated mixtures of high-quality water and glycol, with important corrosion inhibitors added to protect the metals throughout the cooling system. The materials in each engine design determines the type of corrosion inhibitor required to protect it. Older HD engines were made mostly from cast iron. Those systems were protected by molybdate and nitrite corrosion inhibitors. In addition to providing general corrosion protection, these ingredients help prevent cavitation erosion. It's a type of pitting caused by the repeated action of small bubbles bursting on cooling system surfaces. Diesel engines can be particularly susceptible to cavitation erosion. Unlike gas engines, which ignite using spark plugs, diesel engines use compression ignition. The high compression delivers more power, but it also results in intense vibration. As a result, many HD engines are designed with replaceable wet sleeve liners. The challenge is that the vibration shakes the cylinders, resulting in small bubbles to form and collapse on the wet side metal cylinder surface in contact with the coolant. The violent collapse of these little bubbles blasts the liner with pressures up to 40,000 psi. Over time, the cavitation results in liner pitting and eventually engine breakdown. Cavitation erosion can occur on any moving or vibrating part of an engine that is in contact with coolant, including water pumps. Luckily, nitrite is great at fighting cavitation and protecting vital components, such as water pumps and cylinder liners. But nitrites pose a serious problem in some new engine designs. In the quest to make vehicles smaller, lighter, and more fuel-efficient, engines and cooling systems are increasingly being built from lightweight metals, like aluminum. Controlled atmospheric brazing, or CAB, is used in manufacturing aluminum components and has been widely adopted by OEMs and aftermarket part producers. The CAB process involves coating aluminum surfaces with a flux material to ensure strong welded joints. Once completed, the excess flux is removed and the part is finished with a protective coating. The reality is that, given the tight tolerances and intricate nature of radiator cooling fins, not all the flux is removed every time. When coolant fluid circulates through the system, it washes off any residual flux over time, exposing bare metal. Without a protective aluminum oxide layer, nitrite in the coolant will attack the unguarded aluminum surfaces. This causes serious problems. The coolant pH then increases, which accelerates overall system corrosion. It's a vicious cycle that continues to corrode the engine over time. As the metals break down, debris can clog the system and can even lead to total cooling system failure. Nitrites can affect both modern and older engines, as well as cooling systems that have had aftermarket aluminum replacement parts installed. Telltale symptoms of a nitrite aluminum reaction are an ammonia smell to the coolant or black particulate contamination, in addition to a pH increase. If these signs are present, service the equipment immediately to avoid major damages. Because of the increasing adoption of aluminum and other materials in HD engines, many OEMs specify a nitrite-free coolant. A quick way to identify this is to look for statements such as free of nitrite, or products marked as pure or full OAT coolants. Also look for the abbreviation NF. NF signifies nitrite-free. As we've learned in Module 3, OAT formulations differ from each coolant supplier, and some additives can impact performance in some engines. For example, 2-ethylhexanoic acid, or 2-EHA, is long-lasting and widely used in older OAT coolant formulations, but it also has the potential to impart adverse effects. 2-EHA can act as a plasticizer, affecting some silicone-based elastomers. Softening of hoses or gaskets could occur, which could result in leaks. In addition, regulatory bodies have also deemed the substance a potential health and environmental risk. For these reasons, the use of 2-EHA in engine coolant is being questioned by many OEMs. In response, manufacturers have formulated new OAT-based coolants that don't contain 2-EHA. HD Expert engine coolants from RecoChem include premium quality formulations with ProShield, a proprietary recipe of OAT corrosion inhibitors that are free of 2-EHA. ProShield maintains elastomer integrity and more. It helps treat CAB flux contamination and reduces the need for additive extenders. Keeping HD engines running is serious business. Downtime is more than an inconvenience. Serious financial impact and safety hazards can make it a high-stakes concern. But knowing the differences between coolant formulations can help. Always match the coolant formulation to the engine specifications. Read the labels and verify the formulations for the best performance and engine life. In this video, we learned how coolant technology is specially formulated to meet the evolving needs of the HD diesel engine's aluminum components and nitrite-free formulations. In the next video, you'll learn more about HD coolant, including best practices for different segments, trends, and service. Until then, thanks for joining us at Coolant U, where you always reach a higher degree of knowledge.